Hey guys, today I'm going to show you some pre-calculus problems. Although they're Algebra 2 and pre-calculus problems, these often show up in the AB and BC courses. And in my opinion, it is easier to solve them using pre-calculus techniques than it is using calculus techniques. These are the notes that I posted on Schoology. You're free to and welcome to print them out and fill them out as we go along. Or you can do this in your notebook or a piece of paper. Alright, let's start looking at some of these problems and I'd like to show you some patterns. So number one, A starts with A. A times 2, then A times 2 squared. What would be the next term? A times 2, what's increasing? The exponent, and exponent is 4. So the next one is A times 2 to the what exponent? 5th. Alright, 1B. The first term is 3. What's happening to that 3? It gets multiplied by 2. Then the 3 gets multiplied by 4. But I want you to think in an exponential way like before. This is 3 times 2. This is 3 times 2 to the second. This one is 3 times 2 to the what power? Is the third. And then the next one is 3 times 2 to the fourth, which is 3 times 16. And the next one would of course be 3 times 32, but let's represent it as 3 times 2 to the fifth. Okay, let's use exponential form. Might be a little bit easier to represent. So first term is 5, then it's being multiplied by 4. Then that 5 gets multiplied by 4 2 times. Then the next one is 5 multiplied by 4 3 times. Then it's 5 multiplied by 4 4 times. And then very easy pattern to follow. Alright, there's the exponential form. And then we will have first term is 4. What is 4 being multiplied by next is b. Okay? So then we have 4 times b one time. Then 4 times b twice. And then 4 times b 3 times. 4 times b 4 times. And again, like the previous ones, very easy pattern to follow. And then I just want you to think the general case. General case, the first term is a. And then what we're multiplying by repeatedly, like in the previous cases, we're repeatedly multiplying by b. In this case, we were repeatedly multiplying by 4. In the previous one, we're repeatedly multiplying by 2's. Alright, so this is a times b to the first, a times b to the second, a times b to the third, times b to the fourth. And it's a very nice pattern. The exponent is 5, exponent 4, 3, 2, 1. What's this exponent? A times b to the 0. Okay, fits the pattern, alright? This is the general form. So for exponentials, we will have that format. A times b to the x power. Alright, I want you to think the same as before on number 2. But now we want to figure out what the value of b is. What's the repeated term we're multiplying by? So the first term is represented by 8. Second term is a times b. Third term is a times b to the second. The next one is a times b to the third. How would we represent this term right here? The 24 would be the same as a times b to what power? 2, 3, a times b to the fourth. So that means these two are equivalent. Therefore, we can write an equation. The equation would be a times b to the fourth equals 24. And we can perform some algebra there and solve for the value of b. Undo multiplying by 8, we divide by 8 on both sides and obtain b to the fourth is 3. And therefore, we want to undo the fourth power. We're going to take the fourth power to undo it. We're going to take the 1/4, which is the same as the fourth root. That's our value of b. Alright, so that's the term we're repeatedly multiplying by to obtain a 24. Alright, next we will repeat the same process as numbers 1 and 2, but now before we did it in a horizontal manner, let's look at it more in a vertical manner, the way you're going to see it on the table on most of these problems. Alright, so same as number 1, but let's do it vertically. So this is, and I want you to think the same thing. Let's do a times b to the x. Alright, we're thinking exponent form right now. So it's 5 times something. What did we multiply 5 by to get a 20? This must have been 5 times 4. Then what's the next one? 5 times, you know what? I'm just going to represent it in exponent form. 5 times 4 to the second. You guys can use your calculator or whatever, multiply it out. Then it's 5 times 4 to the third. And 5 times 4 to the fourth. I actually did not compute these values, so I'm probably going to skip this part, but I want you to see we can complete the pattern in a vertical way. Alright, next. Same as number 2, we're going to solve for b, but now we have this in a vertical manner. And I want you to think, again, let's do a times b to the x. We're thinking that same format. So our a term, what would be our first term here? Our a term is 3. And we're trying to figure out b. Alright, so the next term must be 3 times b to the first. Then we got 3 times b to the second, 3 times b to the third. And 48 must be the same as what? 3 times b to the fourth. We have an equation like we did in the previous number 2, and we can solve now. 48 equals to 3b to the fourth. We want to undo multiplying by 3. Therefore, we're going to divide both sides of the equation by 3. And get 16 equals b to the fourth. How do we undo something to the fourth power? We're going to take the fourth root, or the 1/4 power. Alright, so if you remember exponents, rules would imply multiply these, then we get a b to the first. And 16 to the 1/4 is the same as 16 to the 1/4 is the same as 2. The fourth root of 16 is 2. So what we're repeatedly multiplying by here is a 2. Therefore, we could say that 48 is the same as 3 times 2 to the fourth. 2 to the fourth is 16 times 3, 48. Alright, excellent. So then we're going to repeat this process, but now I created what is a table, alright, from our exponential form again is a to the b, a times b to the t, I'm sorry. And our a term in this case would be 4. Our initial term is 4, alright? And you can think of it as 4 times b to the 0. That's the 0 term corresponding to that exponent. Next one is going to be 4 times b to the first. And I want to point out again, exponent is 1. What value of t is that one? It's a 1. Next one is 4 times b to the second. The exponent is 2. The t value is 2. Therefore, 8 must be the same as 4 times b to the third. And again, I want to point out the exponent is 3. The value of t is 3. And we have an equation we can solve like we did in the previous problems. Dividing both sides by 4 gives us 2 equals b to the third. How do we undo the third power? Taking the 1/3 power on both sides gives us that b, the value of b must be equals to 2 to the 1/3. The base is 2, the exponent is 1/3. Okay? So let me rewrite that on the side on a more compact form. Imagine if I didn't give you the whole table, but instead we said just 0 and 3. Imagine if we skip those middle steps. I want you guys to see a very nice way of visualizing it. What would be our value of y? Okay, the initial, when t equals 0, the initial value was 4. The a term was 4, and when t equals 3, the value was 8. So I want you to see that b is hidden within this problem. The value of b was 2 to the 1/3. How do we obtain that 2 from this table? Alright, I want you to think about it. It's right here, hidden in front of us. Okay? And if you want to see a little bit more, we did the algebra here. It's not that hidden very well. And then the other thing I want you to realize is, how do we get this value of 1/3? What corresponds to that denominator of 3? That would be very easy to obtain, because the next few problems I'm going to show you, I would like for us to go straight from this table to the equation of y. Alright, so let's write the equation, which we haven't done. It's going to be y equals, what is the a term? The a term is our initial term, which is 4. That one's very easy to obtain. And what I'm trying to point out is the b term is also very easy to get. How did we get the b? Let's figure out, how do we get this 2 using these two values? 4 and 8. 4 and 8. It must have been 8 divided by 4, right? So then that gives us a 2. And the 1/3, what value corresponds to that 3? Look at that. The value of 3 corresponds to that. So then this must be to the 1/3 t. 2 to the 1/3 t can be rewritten as y equals 4 times 2 to the t over 3. If we use our exponent rules, we can multiply these exponents and simplify it that way. Alright, so I want to remind you that what we did in this problem number 5, we're going to repeat here on 6 and 7, but we're going to do it in a more rapid way, okay? But it's the same thinking, alright? So, okay, let's analyze. Problem number 6 is asking us for a and b. What's the value of a in this case? What is our initial term? It is 4. And I want you to think, how did we get the b term really quickly on this last problem? Well, the 2 came by dividing the 8 by 4, and same thing here, we're going to have the b term is going to be this divided by 4, so 24 divided by 4 is going to be a 6. However, there's an exponent associated with that b term, and this was the 1/3, the exponent is 1/3 associated with that exponent here. Therefore, instead of the 1/3 power, this is going to correspond to the 1/5 power. Alright, the b term is 6 to the 1/5. Therefore, we can now write our equation in this form. It's going to be 4 times 6 to the 1/5 to the t. And remember, using our rules of exponents, we can write that as 4 times 6 to the t over 5. Very easy to do. No, not a lot of work to show, and very easy problem. Now, if you remember how to sketch this using exponents, sketch this exponential equation, remember that we're going to do this by transformations. Alright, think of it as the parent function is 6 to the something. 6 to the something, it's an exponential equation that's increasing. Oh man, that's a bad sketch. Some exponential equation like that. It's got a boundary, and normally what would be the y-intercept of any exponential? It would be 0, 1. However, this exponential has a vertical stretch of 4, therefore this is 0, 4. And 1 over 5 is a horizontal transformation. What kind of transformation is that? But it doesn't affect how we sketch it, right? Okay, so that would be the sketch. Let's go to number 7, repeat the same. Look, it's the same type of problem. Let's do it a little bit quicker. What's the a term? What's the initial term here? It is going to be 50. We start with 50. What are we repeatedly multiplying by? And remember that the last problem, it was 24 divided by 4. The one before that, it was 8 divided by 4. So this one must be 25 divided by 50, which simplifies to 1/2. And again, there's an exponent associated with that, and it depends with the number of steps. This problem here had 3 number of steps, so therefore the exponent was 1/3. The one before had a number of 5 steps, therefore the exponent is 1/5. This one has a total number of 8 steps, therefore what's that exponent? 1 over 8. So the equation, I should have written here 8 times b to the t. What would be that equation? It would be 50 times 1/2. I'm just going to skip the step from before. It's going to be t over 8 as the exponent. And let's make a sketch of this. Be careful with the sketch from before. Here we were multiplying by 6. Multiplying by 6, does that make the original value greater or smaller? It makes it greater, therefore it's increasing. But if you're multiplying by 1/2, what's happening to your original value? It's decaying. Therefore, instead of exponential growth, this one is an example of exponential decay. Alright, and remember that originally it would be 0, 1, but this one's got a vertical stretch of 50. And again, this is just a horizontal stretch by 8, so it's very hard to notice on the graph anyway. Okay. The other point I would label, if I would ask you to label 2 points, well look, originally on the table I gave you 2 points. So when t equals 8, the y value is 25. So you can just say 8, 25. go back to the previous problem. I gave you two values for t and their corresponding y. So therefore the second point must be 5 comma 24 on that exponential graph. Alright, here's a word problem involving these ideas of exponential form of growth and decay. Alright, so we have a population in thousands after t years. Alright, so P of t stands for population in thousands after t years, and we're going to rewrite this in the form a times b to the t, the exponential form I just exposed you to in the last 13 or 14 problems. I'm sorry, in the last 7 problems. This is just number 8. Okay, so again, we want to write letter A. What's the exponential equation in this form, which we have done very quickly now? Y is equal to, what's the A term? Our initial term, the A term is 8. What are we repeatedly multiplying by? Remember, it's usually a ratio, 16 divided by 8, so it looks like this is a doubling function. So 2 to the some exponent, how many steps did it take to get there? 3, therefore the exponent is 1/3 to the t power. There, we're done with letter A. Some of you will rewrite it as a times 2 to the t over 3, which is a better way of writing it in my opinion. Okay, next, letter B. What is the expected population after 9 years? So remember that this means, what variable is that implying? 9 years implies t equals 9. Therefore, we have an equation now that we can just evaluate. Oh, my bad. This is supposed to be P of t. We're going to write it as P of t. Population after t years. Therefore, we want population after 9 years, which is a times 2 to the 9 over 3. 9 over 3 is the same as 3. So 2 to the third, a times a, this must be 8 times a, which is 64. And remember, the 64 is in thousands of people, or thousands of whatever type of creatures this population is describing. Letter C. So we're done with that. Look how easy we've done this and fast. When will there be a total of 50,000 in the population? So just like in the previous problem, t equals 9, what's implied by this is that the population is represented by P of t. Therefore 50 must be equal to P of t, and we want to solve for that t. So we're going to say that our equation here is going to be 50 equals to our P of t value that we came up with. Our equation was a times 2 to the t over 3. I think it had 3 number of steps. Alright, and we want to solve for t. But be careful, this is the base is 2. The base is not 8. 8 is a factor, a vertical stretch. Therefore, how do we undo multiplying by that 8? Let's divide both sides by 8. So we're going to obtain 50 over 8 equals, base is 2, alright? So 2 to the 2/3. Alright, and I've shown all my students how to do a shortcut here. If you want to show all the steps, please do so, but I'm going to skip that right now since this video is quite long already. So we know that t equals, it's going to be some form of ln or log of this over log of that base. Log of that fraction over log of that base. I like to use in my calculator ln. ln is some special base if you don't know about it, but you can certainly use log. Ln of this fraction over ln of 2. I don't know why I wrote it like that. Ln of this fraction over ln of 2. Be careful, however, we want to undo one more thing that's happening to the t. We're dividing by 3. How do we undo dividing by 3? Multiplying by 3. On what part of the fraction does multiplying by 3 apply to the numerator? When you enter this in your calculator, we're going to get some decimal approximation, which I haven't done yet, but let me calculate it right now. Alright, I calculated this value in my calculator. I obtained 7.931. I didn't round, I used the 3 decimal rule. Alright, letter D is asking that we convert a to the a times b to the t that we converted into y equals c times e to the kt. This is the pre-calculus way I've shown you today. This is the calculus way that most courses use in AB and BC. But I'm still going to show you how to go from here to here only using pre-calculus ideas. Okay, so I want to remind you of the idea when we can rewrite 2 as e to the ln of some number. That number is obviously right here. E to the ln 2 is the same as that. So using that same idea, we're going to say E3 is the same as what? E to the base. E is the base, the exponent is ln3. E is the base, exponent is ln2. What is 4 then? E to the ln4. Alright. So if I wanted to say 4 to the x or 4 to the t, then I would say e to the ln4 to the t. But you won't see that often on textbooks or solution books. You would see that they write this exponent as the coefficient of that log. So you will often see it as e to the t times ln4. ln4 is a constant, t is the variable. Alright, so I want you to think of this idea when we go to here. So remember that our equation for this problem was 8 was the stretch factor, 2 is the base, which we're going to associate with e and ln. And it was t to the third. I mean t over to the exponent t over 3, I'm sorry. Alright, so we're going to say the same, use the same vertical stretch, but it's going to be now e times, how would we rewrite 2? Remember, we wrote it up here. 2 is the same as, this is 2. This is 8 times 2. However, remember that we want to use this idea of that being the exponent. Therefore, the exponent is t over 3. As we did here, the exponent was t. Here, the exponent is going to be t over 3, which a lot of books will write as a times e to the 1/3 times ln2 times t. And this is what they mean by the value of k. This is c. C is 8. C is 8. This e corresponds to that e. They're the same base. This t is the same as that t. Therefore, the value of k is this right here. Alright? And now we know that this equation is also equivalent to that one. And at the same time, we also already solved for letter E by that same explanation. Letter E is saying solve for the growth factor k, which corresponds to that growth factor from calculus. Alright, therefore, k is this expression right here, 1/3 ln of 2. And that concludes this exploration of exponential growth and decay using pre-calculus techniques only. I hope it was not too long and boring for you.